This is a video from section 12.5 in a Calculus 3 class. The examples will be taken out of the Stewart Calculus textbook, 9th edition. The directions say to find an equation of the plane. Now, we're going to look at problem 31, and 31 says to find the equation of a plane through the points 0, 1, 1, 1, 0, 1, and 1, 1, 0. And so what I'm going to do is I'm going to let P equal the point 0, 1, 1. I'm going to let Q equal the point 1, 0, 1. And I'm going to let R equal the point 1, 1, 0. Now, to find the equation of a plane, we need two things. We need a vector perpendicular to the plane I want, and we need a point that lies in the plane. Well, we have the point. We don't have the perpendicular vector. So let's go over how to find that perpendicular vector. Now we're given 3 points. And so I'm going to form the vector PQ. And remember, to get that vector, we take the terminal point minus the initial point. And so PQ will be the vector 1, negative 1, 0. PR will represent the vector 1, 0, negative 1. And so if I take the cross product of those two vectors, I will get a vector perpendicular to the plane I want. And so N, I'll let that be N, is the cross product of PQ and PR, which I claim is the vector 1, 1, 1. Now, we're going to choose a point, and I'll choose the point P, which is, in this case, 0, 1, 1. And remember that N, this is what we know. So N is the vector 1, 1, 1. Recall. We have A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals 0. Okay? Now, A is 1. I'm looking at the normal vector. B is 1, and C is 1. Okay? So I'm going to take A, which is 1, and I'm going to multiply it by X minus 0. So the first coordinate of the point is my X naught. Okay? Then I'm going to add 1 times Y minus 1 plus 1 times Z minus 1. So I'm going to set this equal to 0. And then I'm going to take X plus Y plus Z minus 2 equals 0. And that would be the equation of the plane that contains all 3 points. And if you want to check, suppose I choose the point Q, which is 1, 0, 1. Ideally, I should get the same equation of the plane. So remember, my normal is the vector 1, 1, 1. That's perpendicular to the plane I want. And recall, if I take A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught, and set it equal to 0, I should be able to plug all that information in and get the same answer. So remember, A is 1, B is 1, C is 1. And then we have X naught, Y naught, Z naught. So in other words, X naught is 1, Y naught is 0, Z naught is 1. And so I get 1 times X minus 1 plus 1 times Y minus 0. So remember, you guys, it's all substitution. Plus 1 times Z minus 1 equals 0. And if we simplify, we get x plus y plus z minus 2 equals 0. And you can see I get exactly the same equation. And I claim if I choose R, I will get the same equation yet again. And that's how we do 31. If we take a look at 32, suppose we want the equation of the plane through the origin, which is just another way to say 0, 0, 0, the point 3, negative 2, 1, and the point 1, 1, 1. So I'm going to do exactly the same thing as I did in problem 31. And I'm going to let P equal the point 0, 0, 0. Q is going to be the point 3, negative 2, 1. And then R is the point 1, 1, 1. Now, PQ, right, we're going to form a vector because remember, we're looking for a vector that's perpendicular to the plane I want. Now, PQ, I claim, is the vector 3, negative 2, 1. Okay? PR is the vector 1, 1, 1. And remember, I need a normal, so I'm going to take the cross product of PQ and PR. Now, a typical question might be, could I do the cross product of PR with PQ? The answer is yes. The only difference is you would just get a vector that points in the opposite direction, which would be totally fine. Now, when I take it, the cross product, I'm going to get negative 3, negative 2, and 5, I claim. Okay? Now, I'm going to choose the point 0, 0, 0. Okay? You can choose any one of the points, and I claim you're going to get exactly the same plane. My normal, let's remind ourselves, is negative 3, negative 2, 5. So remember, this is my A, that's negative 3, my B is negative 2, and my C is 5. And so A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals 0. So negative 3 times X minus 0, so X naught is 0, minus 2 times Y minus 0 plus 5 times Z minus 0, Z minus 0, this is equal to 0. And so negative 3x minus 2y plus 5z equals 0. And I claim that would be the equation of a plane. And if you really want to convince yourself, I would go back and pick like 1, 1, 1 and see if you get exactly the same answer as if we picked 0, 0, 0. And you should. And that's how you do number 32. I want to take a look at problem number 35. 35 is a fantastic question that I've asked on exams. Suppose we want the equation of a plane through the points, or in this case, the point 3, 5, negative 1, and contains the line x equals 4 minus t, y equals 2t minus 1, and z equals negative 3t. This is an incredible question, okay? And I'll tell you why. So let's draw a picture of this. Now, you have a line in the plane, okay, which I'm going to call L. And we have a point here, which we'll call P. And that point is 3, 5, negative 1. Now, you might view this as a different question than 32, but I view it as the same question, because what I'm going to do is I'm going to pick 2 points, which we'll call Q and R on the line. I don't care where Q and R are located. I just need 2 random points on that line. And I'm going to reduce this question to finding the points, finding the equation of the plane through the points P, Q, and R. So let me say that again. This is what we have now. It says find the equation of the plane through the point 3, 5, negative 1 and contains the line. So if the plane contains the line, it contains 2 points on the line. And so what I'm going to do is reduce this problem to finding the equation of the plane through the points P, Q, and R, where Q and R are points on the line. Okay, so that's what we're going to do. So I'm going to let t equal 0. And so we'll call this point Q. So I'm going to replace t with 0. So x is 4, y is negative 1, and z is 0. So we get 4, negative 1, 0. So Q is 4, negative 1, 0. That's a point on the line. And I'm going to let t equal 1. And we're going to call this point on the line R. And so R will be, let's see, x is 3. So we're going to go 3, 1, negative 3. So we're going to get 3, 1, negative 3. So we want the equation of the plane through P, which is the point 3, 5, negative 1, Q, which is the point 4, negative 1, 0, and R, which is the point 3, 1, negative 3. And we're going to go through the same steps. So I'm going to look at PQ. PQ is the vector. So let's see. We're going to get 1, negative 6, 1. PR is the vector. 0, negative 4, negative 2. Okay. So N is the cross product of PQ with PR. So when I do that, I get 16, 2, negative 4, which is fine. Now, so we're going to choose one of the 3 points. So I'll just go ahead and choose the point P, which is 3, 5, negative 1. Okay. My normal is the vector 16, 2, negative 4. And it's the same game. I really recommend writing down the equation of a plane. Remember, we need a point, we need a normal for the plane. So a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. So we get 16 times x minus 3 plus 2 times y minus 5 minus 4 times z minus a negative 1, and we're going to set that to 0. So when we do a little algebra, we get 16x plus 2y minus 4z. And we're going to take 16 times negative 3, which is minus 48, minus 10, minus 4 equals 0. So 16x plus 2y minus 4z, and I believe that's minus 62 equals 0. And so I want to divide everything by 2 because we can. And so therefore 8x plus y, right, minus 2z minus 31 equals 0. And that right there would be the equation of the plane. And if we take a look at, let's see. Let's take a look at 36. So we'll do that one. Suppose we want the equation of the plane. That passes through the point (6, negative 1, 3) and contains the line with symmetric equations and these symmetric equations are x over 3 equals y plus 4 equals z over 2. Okay? Same idea as 35. The equation is written a little bit, of the line is written a little bit differently, right? So we know P is the point 6, negative 1, 3. And so we need 2 points on the line. So again, remember, you have a plane, you have a point P, and you have a line. And we need to find essentially the equation of we're trying to find the equation of a plane that contains a point and this particular line, like so. And so we're going to reduce this question to finding the equation of the plane through the points P, Q, and R, where Q and R are 2 arbitrary points on the line. So if we can do it a couple of ways, right? So I'm going to let y equal negative 4. Okay? So we're going to call this Q. So y is negative 4. And that's going to tell me that x is 0 and z is 0. So we have the point 0, negative 4, 0. And R, well, if I let, we could do this. If x is 3, right? 3 divided by 3 is 1, right? So we're going to let x be 3. And then this y plus 4 has to equal 1. And the way that works is when y is negative 3. So we'll call y negative 3. And then z has to be 2 because 2 divided by 2 is 1. So these are 2 points on that line. Now, PQ is going to be the vector negative 6, negative 3, negative 3. And PR is the vector negative 3, negative 2, I believe negative 1, right? And so my normal, right, same game, is PQ cross PR. And when I go ahead and do that, I get the following. I get 3 minus 6 is negative 3. 6 minus 9 is negative 3, but we have to take the opposite, so you get 3. And then 12 minus 9 is 3. So we have a point and we have a vector normal to the plane. So in this case, I'm going to choose Q because there's lots of zeros. So we'll choose Q. Let's go back. Q is 0, negative 4, 0. My normal, let's go find that out. That's negative 3, 3, 3. Now, again, A times X minus X naught plus B times Y minus Y naught plus C times Z minus Z naught equals 0. Now my A is negative 3. My X naught is 0, so it's X minus 0 plus B, which is 3, times Y minus a negative 4, like so, plus C, which is 3, times Z minus 0, and this is equal to 0. And I'm going to divide everything by 3. And so we get negative 1x plus y plus 4 plus, well, we divided by 3, so it'll be just 1z equals 0. So negative x plus y plus z plus 4 equals 0. And that would be the equation of the plane that we are looking for. Now, if we want to convince ourselves, what if we chose a different point? And I'm going to suggest we choose P, which is 6, negative 1, 3. And N is the vector negative 3, 3, 3. And so negative 3 times x minus 6 plus 3 times y minus negative 1 plus 3 times z minus 3 equals 0. So it looks completely different, but if all worked well, it's going to reduce to the same plane, right? It's going to reduce to get exactly what we need. So I'm going to divide everything by 3. So we get the opposite of x minus 6 plus y plus 1 plus z minus 3 equals 0. And so negative x plus 6 plus y plus 1 plus z minus 3 equals 0. So negative x plus y plus z plus 4 equals 0. And if we go back, it should have been the same thing. And sure enough, it is. And so that's going to conclude this video for section 12.5. And we worked on problems 31, 32, 35, and 36. Thank you.